listeners. Well, here's another look at the Tec Pegasus and the Python 3 program running on Flask that I've been working on. So I made some more improvements. In the last video, I had shown you that all these different bands here had volumes that were pretty much equalized. And I'll show you how that works. So I can hit one of these here, like 160 meters, say. And here's 80 meters, 60, 40, 30, 20, 17, 15, 12, and 10. So now the problem with this was I'm usually an upper sideband or lower sideband. Like here on 80 meters, I'm on lower sideband. And then when I hit AM, it would be so loud, I would be like thrown out of the seat from the objective obnoxious static. So now when I press AM, it doesn't raise up very much. So I had to put basically a variable in this program that when I hit one of these, it would save the volume. And then when I hit, say, AM mode, it would take that volume number and subtract, say, like 10 or 15. In fact, I can show you that code. So that stuff is here where I go to AM mode here. If I can find that part. CW, FM, okay, AM's up here. So I got special cases for AM mode. Like when I hit this AM button here, I first check it with the broadcast band. I'll set the step to be very large. And let's see here, what do I have here? Okay, that's set mode function. That sets the mode. However, I do have an AM mode in here somewhere. Let's see where it is. It's down here. There it is. No, it's not it. Finally, okay, yeah, here's AM mode. So now when I enter this thing, I check if the band is 160 or 80 or 60. So where one of these buttons punched or pressed. If that's the case, I'll lower the volume by 10. So I'll save this local volume that these initially set the volume to, and then if you go to AM, I'll subtract 10 off of that. And that's how that works. And for 160, I'll take off 15. So that's been working out pretty well. So now I'm wondering if this thing works right. If I go, say, to 40 meters, and I go to LSB, which I'm on, AM, back to LSB, I guess it works right. It does decrease the volume, and when you go back to LSB, it doesn't restore it. So that's a problem, which I gotta fix. So I almost need to have like a an old volume marker on there and fix it that way. Well, that's a pain. I just thought, yep, you better do that too. Wow, it never is easy. However, it doesn't go below that. But the volume does lower. So that's something else to fix. But I do like now how I got this thing fixed as to where if I have some frequency of say like 4 decimal places on sideband and I go to AM, it'll now round it up. And back to sideband, you can see that it did round it up. So that's what I wanted for AM. I wanted AM to have 3 digits of accuracy and sideband to have 4 of them. And if you're on, say, some oddball frequency like this would round up to 5, and that's how it should work. So glad that's working. And CW has 5 decimal places. And again, going to AM, that'll round down or round up depending. So that took some work too. So here's some of the sideband people. So I'm pretty happy with how this finally turned out with AM. I still got to fix this volume problem now that I just noted with this video, but otherwise I'm pretty happy with this thing. So here's the band scan again for finding if the band is active with WWV. Nothing there. Here's a little bit there. Activity there. 15 megahertz is strong. 20 not so much. And here's CHU. That's coming through on 20 meters. Pretty well. Or not. Okay, here's 160 meters, 80. So these, I always go to the FT8 frequency. There's some FT8 there. FT8 and 20. FT8 on 17. People talking. And now I know where the band edge is. I never knew this stuff, so now I put the stuff in here. So you know when you're getting toward the edge, it'll just flash off and say you're at the edge of the band. Here's 15 meters. This has been kind of dead. It's about 2:22 p.m. here on a Sunday afternoon, June 5th. That's kind of dead. This is kind of dead. Of course, I have CB in here too. There's CB. Go to AM mode. In Las Vegas, there's people on channel 19 around here, it seems. Right about there. Seems kind of dead today. That's about that. Well, thanks for watching. Yeah, I'm getting some progress in this thing. Oh, I don't know if I showed the watts thing here, the reflected power. So I do capture peak power here, and I do capture SWR right here. So I'll show you how that works. So I'll go to 40 meters here. Put my antenna tuner on 40 meters. And transmit enable, transmit power, 15 watts, bandwidth. Okay, let's do a tune transmitter here. You can see I got a lot of watts going back. Holy smokes. That's really bad. I'm on 40, okay. I'm tuning down the antenna tuner, and now it's low. So that's pretty good, 2 watts back. Okay, so the reason why it's different is I never transmit down here, so that's why I'm in CW mode here. Transmitter off. If I go, say, up to like, say, right up to here, 7.3, 7.28. The antenna tuner will probably need a pretty good tweak again. Transmitter on. Yeah, so the antenna tuner is rather narrow here. So I can take this down with a reactive again. I'm watching my SWR meter on the antenna tuner. And it goes down, there it is. So, yep, I can pretty much get it 0 watts. Let's raise the power, 25 watts. Still nothing back as far as the radio is concerned. 60 watts. Nothing back, that's pretty good. Let's go to 100 watts, full power. 2 watts back, not bad. Not bad at all. Okay, and I can probably show you the problems I've had with the frequency control in this thing here. If I can bring up KFS. Let's see, KFS. Here's Kiwi. SDR.com. Okay, that's wrong. That's not working out too well. Okay, that worked, I think. Let's bring up KFS. This is in Half Moon Bay. Here we go. So now I can listen to my own transmitter from Las Vegas to Half Moon Bay to the Bay Area, and looks like 7260 is clear. That's where I've been testing. So there's 7260 right there. Let me tune this thing down to 7260. 7260. Okay, so if I go to CW now and I transmit, and now I'll go to CW here, transmit. There's my signal in Half Moon Bay, so I'm right on the money here. If I go to FM mode, even though I can't transmit with FM, I'll just show you the carrier here. That's on the money. If I now go to AM mode, this is where the trouble begins. There's AM mode, 7260, it'll be a little off. So that's a bit off, not too bad. But now I got to really improve the calculations on the Pegasus. If I go to 7261 and invoke AM, I'm still at the same frequency. 7262, invoke AM, It moves to 7261, 62.5. Sort of works. If I go to 63, invoke AM, same frequency. So I got some work to do to figure out why this is broken. Everything else works as far as frequency, but AM. 7264. Now it goes to 65. And 65 remains 65. So it's close, but not perfect on AM. There's 65, same frequency. Okay, let's go back to 60. There's 60. Invoke AM. Let's try to modulate. Go to AM here. Narrow AM. Turn the volume down on the receiver here. Turn it up. Okay, there's Half Moon Bay. AM testing, AM testing. 1, 2, 3, 4, 5, test. AM test, KB3 Whiskey test AM. AM testing from a Pegasus. Las Vegas to Half Moon Bay. Testing 1, 2, 3, 4, 5. So that works. We can try LSB. KB3 Whiskey test to Half Moon Bay. That works. Let's go USB. KB3W test to Half Moon Bay. KB3W test to Half Moon Bay. All right, so that about completes my little demo here. Yeah, this thing is basically working. I don't really want to put any more time into it. It's old technology. The radio came out in the late 90s, and I guess I've learned some JavaScript with this thing. Yeah, I've learned. I've also learned how to encode ASCII again using binary with Python 3. So yeah, this wasn't a waste of time. And I got a usable program now, so I guess it's good. Can still scan 40 meters here. So the AM people hang out around here at like 90, 290, 291, around here. It's been kind of fun to listen to those guys once in a while. All right, that's about it. That's the progress so far on the Tec Pegasus interface on macOS with a Python 3 program. In fact, the program is still running here. Let's see. Show you the program running here. Here's the program. So it's taking requests from the browser. You can see them all right down there. So I've kind of been picking away at the frequency here for AM, trying to get it figured out. I actually leverage a lot of this transmit frequency stuff from a gentleman who wrote the stuff in C many years ago for his project. The documentation wasn't too clear on how to make this work for transmit. It was clear, but I couldn't figure it out. So anyway, yeah, here's the whole program that makes this thing go. I leveraged all his stuff here, which is all C code for the commands. This stuff here came from a guy who wrote this stuff, I think, in Finland or somewhere, for controlling an RX 380. And I simply took his program and modified it. There's the serial device on the Mac that I open. Baud rate. So this has been quite a long program now. I can probably clean it up and get some of the junk out of it that I don't need. Here's stuff from the documentation. It's not too good. I mean, yeah, it's on the mark, but Tentec added AM later on with a firmware upgrade, and documentation didn't catch up. So I'm still not sure how to tune AM transmit on this thing, but can't put too much time into a really old radio. So that's how I've been working this thing. There's a lot of code in this thing, just decoding statements from the web browser into something meaningful for the ASCII command to the Pegasus and make it go. Probably about a month of work on this thing, month and a half on and off. Anyway, and here's the actual part from Flask that intercepts the commands from the web browser. So say LSB, and there you are. Okay, well, have a great day. Thanks for watching, and I hope this video was at least fun to watch. Take care.